is this going to work for me? Or like, how is this going to make things worse? And there's a lot of cost and vendor lock-in questions, and also just like how do you do it in the first place? And so like from all this, trying to learn more about the systems and the architecture that powers this stuff, there was this crazy idea, and that's like, well, how can we get more information and introspect more about the serverless environment? People say, yes, it runs on servers. We know it runs on servers, and we know there's some kind of hand waving about they use containers. Would it be possible to actually kind of learn more? And so, like, there was this idea that, well, what if we just ran the SSH process, and we were able to basically have a pseudo shell in a lambda to kind of explore and learn more about the environment. And there were a ton of problems with that, but using an SSH tunnel, it is possible. And kind of the data and the exploration basically came out of that, which is kind of cool. But from a metrics perspective, if you want to understand Lambda without doing something like this, where you run an SSH process, you kind of get a couple typical metrics that are provided by mostly every function service vendor. The first is the error count, so just the raw count of errors. You go into logs typically to get more detailed information about what that error was. There's also the function invocation count, so that's how many times the function was invoked. And then, of course, the duration itself, the duration in milliseconds. And the invocation count and duration are pretty important because those are two really important metrics for what your serverless bill will actually be. So you care about them inherently because it determines your bill, but the duration itself I think is the most interesting from a performance perspective. And yeah, part of that's driven by cost, but when you're build in AWS Lambda's case in 100 millisecond increments, that idea of wanting the function to be really fast, especially in the worst case, becomes pretty important and pretty interesting too. And just a really quick background on like the function lifecycle, it's not that dissimilar from a real function, but there's some set of event triggers. And I've tried to make this as like cloud vendor agnostic as possible. So generally speaking, this would apply to Google Cloud Functions or Microsoft Azure. But because of just Lambda's sheer market size, this is generally specific to that, but I've tried to generalize it as much as possible. But in any case, you have this set of event triggers, and there are typical ones like an inbound HTTP request, but there are also like there's this increasing variety of them too. Infrastructure health events are one of the newer ones. So if there's a cloud vendor, well, in this case, like an Amazon health event, that could potentially be a trigger. Obviously, operations on object storage buckets, on databases, and of course, you can just call the API directly or through an API gateway. So this list is ever growing, and it's pretty interesting. But those triggers, of course, run some function, and that function is written in one of 4 runtimes in Lambda's case. You bundle your dependencies in a zip file, and that's like what gets created in this environment. And then how long it runs, of course, is the duration of the function. And then the function ends. The timer of how much you'll get billed for it ends. There are a couple ways it can end. It can have an error. It can have an error like in the exception sense, or you can actually exit the process itself using a non-zero exit code. It can time out, so all these functions have a maximum lifetime of 5 minutes in Lambda's case, and that's configurable as well. So you can say, I want my function to end after 5 or 10 seconds. And then, of course, the most common one, the one that most people want, is there's some result. So then there's like a callback, and then the function can perform some work, and say it succeeded or pass it along to a different service. But with all that, and especially with function duration, there's like one extremely, extremely common question that you build this, you look at metrics, and you're like, well, what's going on? And that's what you notice pretty quickly. It's like, oh, like why does my function invocation time vary so much? It's the same function. It has very steady traffic. So this is function invocation time where a function's invoked once every minute over, I think, about a day and a half or so, and you notice it's fairly spiky, and that kind of gets to the heart of some really interesting Lambda performance questions that I kind of got interested in as well. And you can say, for this function itself, we're talking about invocation times under 100 milliseconds or so. So basically, if it's under that threshold, the billing's the same. So kind of why care? And I think one of the really important callouts or the reasons to care is that if the lambda's triggered by some user interaction, and the threshold for something that's like human perceptible in time with user interaction based on a bunch of studies from a long time ago is around 100 milliseconds. So if it's powered by, if the lambda is triggered by some user interaction, so someone's waiting for it, it's like some physical person is actually waiting for it to complete, there's a really good, other than cost benefit, just kind of a user experience argument to make it fast. And if it's not, I think you still get into you want to make it fast, and you also want to monitor it for cost reasons. But part of that spikiness, you'll kind of see this discussion of cold starts and warm starts. And the idea there is that you have a trigger, and sometimes the function responds faster or slower. And with a cold start, the thing is that function, it has to go through some initialization step. So every time you call a lambda function, it's not necessarily like reinitializing and loading in all its dependencies over and over again. There's some optimizations on the server side of, those dependencies have already been loaded and the function's in like some state where it could more readily initialize. So the cold start would be the dependencies, the runtime has to go through that setup phase, that initialization phase, versus being warm where that handler, the function inside the lambda, is basically more immediately ready to be executed. And you can see this play out when the function isn't called very frequently, it becomes cold, so it has to be recreated. And I was super interested in like trying to figure out more about like when does a cold start happen, and kind of why? Like why are cold starts a thing? How do you optimize in the first place? And and kind of talking about lambda discovery. One of the ways you can do it, there was a talk at the Chaos Computer Club conference in November that did a similar thing, but nothing stops you from kind of executing commands inside of Lambda. So we know it's a container environment, as has been told in the documentation, and so nothing really stops you from doing things like running who am I, in the process. You can get the output and see things like, okay, so when I run a Lambda and I run who am I, in this case, I'm some SBX user 1066. But the insight there is that, hey, this really is just Linux, and we can start to learn more and more about it by just iteratively running these commands. But the problem is that doing that in a Lambda, you basically write a new version of the Lambda function each time you want to run a new command, and that's extremely slow. And so in terms of like, over-engineering like a way to get around that, it turns out that you can basically use Go. And Go has some really nice high-level SSH libraries for servers and for tunnels as well. And the reason that tunneling is so critical is that AWS Lambda doesn't allow inbound connections. So even if you started a server on a non-privileged port, you can't bind to privileged ports because you're not root, since we know we know the username. Even if you have a service running for 5 minutes, the maximum timeout, you still can't get to it because Lambda wisely doesn't allow you to have inbound port access to a running function. Makes a lot of sense. But using an SSH tunnel, you can get around that. So you build a binary that creates a tunnel to, in this case, it was my local laptop using ngrok because my laptop's obviously not exposed to the broader internet. You execute this binary, and then you max the Lambda timeout. So you basically have a tiny, Linux container server running for 5 minutes you can interact with on a shell. The thing about that is it exposed, this brief aside, like just some Lambda architectural advice. Like I'm not the first person to say this, but like the old advice is, of not writing super long functions absolutely applies in Lambda's case. The vendor-specific code in this case, and it's on GitHub, but there's a really nice separation between like the Go binary, basically your libraries, and the code that handles the invocation trigger. So I think something doesn't get said enough in the vendor lock-in concern, which is super legitimate with all these cloud function providers, is that if your like secret sauce library or business logic, whatever, is abstracted in a nice library, then hopefully, the portability becomes less of a major concern. You don't have a 4,000 line long, code in a block. It's in a library that then is run from the function handler. So I think the idea of, portability and keeping the handler itself as short as possible is totally valid, and it's very old advice, but still really good advice, especially in this environment. But the end result is, using Go in the tunnel, you get this kind of janky shell that times out. You can also, because it's Go and you have access to the terminal environment, you can also like use lambda as the prompt, which I enjoyed. But we have this environment to actually explore lambda at up to 5 minutes. And the idea, their goal was to try and learn more about the environment. And one thing, if you kind of dig around in the file system a bit, is the process information pseudo file system is totally available and mounted in Lambda. And because we know it's just a container, so it's using C groups, that's also pretty obvious from exploring. Most of this data in proc predates C groups. So when you explore the file system, you quickly realize that it's telling you information about the underlying infrastructure of the Lambda host itself. So not the container, but the host. And so if you look at proc CPU info, for example, you realize it's a 2 CPU Intel Xeon machine, a relatively recent vintage. If you look at the memory, it's about 3.7 gigabytes or so. And if you look at all the kernel modules it's loaded, you see this special one, IXG BEVF, which is the AWS EC2 10 gigabit network driver. So it's using the host itself, so where your Lambda and other Lambdas are running, is actually these specs, as it turns out, exactly match a C4 large EC2 compute instance. And C4 instances are compute optimized VMs. And I think that's interesting in the sense that if you're an AWS architect and you're building Lambda, you could choose essentially any instance type. But C4 larges in particular are optimized for computing tasks. And I think that provides a really interesting hint of what Lambda's good at, just from their choice of VM to run it on. And I think, from that model, we're like, okay, cool. So Lambda is just running on an EC2 instance that's C4 large. We also know that it has this 10 gigabit Ethernet connection. And so, if you have a tiny Lambda function, it's running on some VM that's managed by AWS, one of many, perhaps. But obviously, you're sharing that space with a lot of other VMs. And the kind of cool thing is you start to see that there's this theoretical maximum limit of how many lambdas could actually run on a C4 large instance, and that's the memory size. So 3.7 gigabytes of memory. The minimum lambda function size is 128 megabytes, and so if you divide that, it's roughly 30. But 30 is a really interesting number because that's also the maximum number of IPv4 addresses that a C4 large instance can handle. So again, we're kind of getting these hints at well, what's the theoretical maximum number of lambdas that AWS is able to pack on this VM, which they obviously, for cost reasons, want to maximize the utilization of. You also see that you're sharing a single 10 gigabit Ethernet connection with potentially several other lambdas. So for I/O heavy tasks, that's something to consider. But the other thing is, one question that I was never clear about is why in Lambda do you configure them based on memory size? Why not say I want this share of CPU? But I think it's kind of an interesting hint when you think about it in terms of a VM. As you increase your memory size, you're actually just taking up more of the VM space. So memory, as they've kind of hinted at, it's not just the amount of memory of the VM, but it's also the implicit CPU share as well. So the larger the lambda, you can think of as you kind of turn that memory dial up, you're also just getting more of that C4 large instance. And of course, in terms of the cold start thing, it also gets super interesting. It's that, not all of these functions, there's some number of functions on the host, but they're all not running at the same time. Some are actually kind of in this frozen or cold start state. And there's a way in code to actually detect that. And the way to do it, this is an example in Node, but it would be similar in any other language, is that the handler function is what runs on a trigger, but the initialization outside of that function, the so-called sets to true, that's where you would load libraries or dependencies. So the first time the handler gets invoked, you're able to detect pretty easily whether it's a cold start or not. And from there, we can kind of grab the data and do some interesting analysis with it. But when the function's not running, it also kind of brings up is like, well, we know this isn't always running because they want to maximize the utilization of that instance. So like, what state is it in? You know, it exists on the server. It's been run once. It's kind of ready. It's been warmed, so it's ready to accept a new trigger. What's it doing? What's going on? And you know, this question of how are they frozen is kind of interesting. And there's a C group feature that I learned about. It's the C group freezer. And using some special signals, it basically tells a set of processes. So basically, whatever's running in your Lambda container to kind of enter this frozen state. And apparently, it was developed for high-performance computing. Some interesting stuff there, but it's kind of cool to see them utilizing this for basically trying to densely pack those Lambda functions into one of those EC2 hosts. And so from there, like we want to keep it warm as long as possible. And the current hack for kind of warming a function, so it's ready to basically not reinitialize, it doesn't get kicked off that VM, is to basically ping it every few minutes. And the suggested magic numbers around 4 or 5 minutes. And you can actually use an AWS CloudWatch event. So basically, this is built-in cron for Lambda, and you say just invoke the function. You know, I don't really care what it does. Just make sure you invoke it every 4 minutes, and the Lambda will run in the function. And you know that works well if your Lambda function only has isn't concurrent. So there'll never be 2 triggers that happen at the same time, and you need to run multiple Lambdas because a Lambda can only fulfill 1 trigger at a time. So if you go much above that, you would run into the problem where the second function isn't warmed yet. So this is really only effective for non-concurrent execution. There are some interesting projects and techniques to try and make warming more complex. But from there, we basically use CloudWatch's triggers. So this is kind of think of it as event-driven logs. So we're going to use just console log, and there's going to be a special message in there, and that'll trigger another Lambda function. And that other Lambda function, we're going to put it into a metrics database. This is New Relic Insights in this case. And we're going to start to visualize those cold starts. So if we're warming a function every 4 minutes, and with most like Lambda performance data tests, it turns out like over a couple day period is best. You see that for a non-concurrent Lambda that we run every 4 minutes, we can get it to be warm. So before it reinitializes, about 7 or 8 hours. And this varies depending on a lot of factors. It's not a constant, I guess is the takeaway. But in this case, not too bad. But if we start scraping more of that data from the proc file system, it gets pretty interesting, and in particular uptime. So uptime is exposed in host. That's the amount of seconds since the host has been booted. And we're also going to grab the host name. The host name appears to be the internal IP of the EC2 instance that these Lambda functions are running on. And so if we basically just plot the host time, we're grabbing this every minute, we can see some really interesting stuff. First of all, it appears that Lambdas do jump hosts. So every 6, 7, 8 hours, your Lambda function moves to a new host. Obviously, because it hasn't been run on that host again, a cold start happens. But the other interesting thing is that there's some maximum limit to how long these hosts actually exist. Lambda's fleet of EC2 instances appear to have some sort of maximum lifetime before they get recycled, scaled up, or scaled down. That seems to be around 11 or 12 hours. But the other really cool thing or hint from the host name is that you can actually look at the subnet, the IP addresses, and you actually see it hopping different subnets. So .12, .11, .13. I thought it might rotate equally between all 3 major subnets, but that we don't know the algorithm. But the interesting thing about that is the number of major subnets, 3, is the exact number of availability zones in the region this was running on. So per the Lambda documentation, availability is built in, and you can actually see that in the host name. It really appears, we don't know, but it really does appear to be rotating between all the availability zones. So in brief, if you wanted to to kind of build your own Lambda or something, there's kind of this high availability component. Or if you're evaluating a Lambda service, it would be good to ask, like, well, does this handle availability in multiple zones? There's some notion of the VM fleet, so the cluster that you're running these small containers on, it's elastic, and it's elastic in the sense too that there's some methodology of keeping those containers in a state where they're very quick to respond to subsequent requests. So yeah, there is some like initialization, the cold start cost, but they've leveraged this C group freezer to kind of keep that on the host and to be able to pack those lambdas more densely in there. And of course, all that's probably built on some very, very good scheduling algorithm. And I think that's I could see that maybe being the ultimate like kind of price differentiator for Lambda providers. Like how does one person do a much better job of getting more out of a Lambda service they provide to customers? If they had like kind of a best-in-class algorithm, they get more utilization out of those hosts and physical servers that actually is powering this stuff. And that I think gets to a really interesting point that I'm not the first to make, and that's that this better utilization of the hardware across dozens of data centers and regions around the world is that there's kind of this interesting environmental angle almost. It's like if you have 100,000 servers running these, by kind of providing this external service to customers, yeah, you save money. There might be an interface or way that it's easier to use. But it also allows you to basically use that underlying hardware in a much more effective way, and that's kind of an important thing because we know that generally speaking, people aren't great about provisioning perfectly. It's a really hard job. But by kind of chopping it up into smaller pieces, putting it in a bunch of global data centers, there's almost this angle that hardware, you get more out of your money. And I think in the hints of the instance type, the C4 large instance, that instance type is pretty close to being retired by AWS. The C5 instances are next up. So an open question is, will they be using basically the previous generation of EC2 compute instances to basically provide this Lambda service, which allows them to get more out of that hardware. There's some replacement cycle that we don't know what it is, but kind of is there this angle that from the service provider perspective, that utilization has some cost benefits, but also it allows them to basically use their hardware in a better way. And so like we're stuck, from a consumer perspective of this stuff, you still want to measure. And with anything or with any new technology, there's kind of this tech and people balance. From the technology perspective, you can measure cost. You can measure and kind of mitigate worst case performance with things like function warming, or even making the call in the first place whether it even matters. Is your function so fast that no one really cares if it takes an extra 200 milliseconds for your particular application, or would that be super critical? So some kind of calls you have to make as a developer for this stuff, but it's kind of weighed against the much harder, and I think some things that people are a lot more excited about fast in the first place, and that's just the operational or development benefit of using them in the first place. And so so from that, we're stuck with the reality of actually getting this in production. And I think there's this great tweet from Michael Ducey about containers, like this learning cliff. And, he makes a really excellent point with containers. It's like, yeah, cool, you just ran Docker in, locally on your machine. But there's all of these other operational considerations to, actually get to production. I think we're in a pretty similar place with serverless. So, I mean, yeah, sure, you don't have to worry or think about servers anymore, but the monitoring, managing cold starts, or even deciding whether cold starts are a performance issue for your app in the first place. There's a lot of really hard questions around versioning and deploying. In particular, if you have a really high throughput, like, API service built on Lambda, when you redeploy, you're going to get cold starts for all of your concurrent requests. Like, what's that impact? Is it a problem, or is that actually a really big problem that would basically tank your performance whenever you do a deploy? And finally, security and of course monitoring. How do you make sense of these fairly high-level metrics? Do you need to gather additional ones in the first place? And so, like, I don't know. I think there were really no huge surprises here. And I think with so many new and hyped things, we can kind of think that, yeah, this isn't a silver bullet necessarily. This isn't going to change everything in IT as we know it. It's a really nice way to, you know, potentially run certain types of things at a lower cost with some nice benefits in terms of the abstractions. And maybe if you're a developer, it's an easier way to develop or kind of build things that for your performance needs, for other needs, if you're integrating with other services, it works out well. But we do know that it seems really well suited to basically the original example of Lambda when it launched, and that's these computationally intensive, occasional but latency insensitive tasks, like creating a thumbnail image from a larger image. And I think how I want to end, and I think the really interesting thing as people explore serverless more and decide to use it or potentially not use it, it's that we really, as a community of people that looking at this, we've just got to measure and share more. And I think understanding cold starts, how people are dealing with them, and what those metrics are, and how it impacts performance is a really big kind of to-do for everybody. And if you're kind of going down the serverless path, definitely encourage everyone to kind of share the data, and I think it's a really interesting discussion to be in right now. And with that, yeah, thanks very much. I think we have time for one or two questions if anyone has any. Okay, if happy to answer any questions. If yeah, sure. That's a really good question, and fortunately, there's a fairly new Amazon product called X-Ray. And X-Ray is basically their cross-application tracing, distributed tracing tool, and that was launched less than 2 weeks ago. So again, it's kind of the bleeding edge of Lambda right now, and I personally agree with you. I think that understanding that end-to-end latency is going to be a really critical thing for performance, and it's like less than 2 weeks old at this point. But I think in terms of, if you're not going to use that, right now the best you can do is basically ingest that log timing information and then tie that to other components. And there are some interesting ways to do that. But I think the forward-looking thing, at least in the AWS world, most likely will be X-ray related, although I haven't had a chance to look at it yet. All right, in the back there. Yeah, absolutely. So I believe all of the organizers' slides will be posted in a bundle. I'm gonna be uploading this shortly. I'll also post them on Twitter and stuff. But yeah, those links and there's some blog material too. I'll be posting it very shortly, and the slides will be available through the DevOps Data organizers. And I think with that in mind, we're just about out of time. And thanks very much. Yeah.
For coming out. Test, test. 1, 2, 3. Test. Okay. Great. Right here, yeah. I do not. I typically don't like it. Okay. Should be good. Test, 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 test. This is okay. Test. Okay.
All right. So where do you want the mic pack? Do you want it on your belt or in your pocket?
Pocket. link to the slides.
Fantastic font. All right, everybody. Here today we have Ken and Jack from Invisium here to talk about modern software security and how to keep up with it.
Okay, before we get into the meat of this presentation, we're going to set the tone for this conversation. Organizations have been bit in the past. We're going to go through some examples of how that's happened. Datadog is a service used by folks who want to monitor their cloud instance. Datadog was breached. The data that Datadog stored were access keys to customer cloud environments. This is how they noticed that they were hacked. Someone was using customer access keys to leverage access and exploit AWS. Here's an example of putting something out on the internet accidentally, moving too quick for your own good, and accidentally exposing a service, in this case MongoDB, or a database in this instance. When attackers discovered these Mongo database instances, they stole the data and left a ransomware note. In this case, with Redis, the attackers left a ransom note, but didn't pay. When paid, did not restore the data. The data was just deleted. That's it. This is an example of a business that went out that is no longer a business because their AWS account was exploited. It's the only example I can point to of an organization who's no longer in business due to this sort of hack. This is an interview of regarding a talk that Chris Gates and I gave at RSA. We're going to get to some of the topics that we discussed in that presentation a little bit later, but the general gist is, time after time, we broke into tooling centered around DevOps in the sense of tooling used in DevOps environments. So we showed examples of how we did that, how careless mistakes and not understanding the security models of tools led to these exploits, but we also provided solutions.
So I'm Jack Menino, test. You hear me? Okay. So I'm CEO at Invisium. I don't get to do as much computers as I used to, so I have to squeeze all my coding into nights and weekends. Do a bit of development, Scala, Play Framework, Akka stuff. So when I do get to play with computers, fortunately it's the right code. And so we're very microservice oriented internally. So some of the stuff when I get to my part will be just kind of based on pains and challenges I've kind of come across while rolling out a microservice architecture of our own.
And I'm the Chief Technology Officer at Invisium, so your concerns are my concerns. We share the same problems. One of the talks that I've listed there at the top was at CERN, and that was an amazing opportunity to go to speak to those folks. And if you're not familiar with CERN, I think most people in this room probably are, but they're the ones who developed the LHC, the collider. They're doing some amazing things, awe-inspiring things, but at the end of the day, when you talk to their security team and you talk to their developers, the challenges are still the same. It's still big data. It's still trying to analyze that data in a meaningful way, and a security team trying to keep up with all the new tools that the developers need in order to do their job and secure those devices, those databases, those technologies. So, we're not here to just talk about the bad, we're here to talk about the good. We want to talk about solutions. That's primarily why we're here. We like this technology. We think the technology is beneficial for the community. We wouldn't be here if we didn't believe that. We want you to use it, but we want you to use it securely. If you don't, and we'll show more examples, it can have a critical impact to your business. So we're going to break this talk out into several sections. This isn't necessarily the order we're going in, but we're going to talk about code as infrastructure, cloud technology, microservices, and a little bit about development methodologies. There's a little bit of evil, right? Okay, we're security, that's going to happen. A little bit of solutions, so we're going to be nice. We're going to
Actually, kind of looks like my hair too. So.
It's got the man bun right now. Going right into it, we don't have much time. We have to get right into it. Cloud and infrastructure challenges. So, code repositories now equal a network. Quite a difference. Because of that, software developers hold the keys to the kingdom on the machines they develop software with. That's scary for security people. There are some security teams who are already caught up and already ahead of the curve, and they're talking about the cool things they're doing. And we're going to give a couple links to some of those teams. But the majority of the people that we come across are, we'll say, immature in practices and policies to handle this, as well as just automating technology to secure their environments. When we talk about code as infrastructure, CloudFormation, Ansible, Terraform, these come to mind. The old process was a software developer, she submits a request to maybe the network guy, gives a thumbs up, nothing happens. The business cannot live like this, right? This was very disruptive. So we went to a new process, a different process. All jokes aside, this new process, although beneficial to the business, left a shift in the responsibility of whose shoulders it was on to secure the environments that they're standing up. You had network administrators, system administrators, and they had processes that they had implemented from learned experiences and shared experiences, and now all of that's gone. And here's where the security team's at. They're trying to figure out how to monitor these assets. Things are getting spun up and down. They're trying to figure out how to inventory. How do they even know what they have? And then understanding the technology itself is a learning curve for security. I mean, I think you'd agree. Not all security people are great coders. So there's a bit of a learning curve there. As I said, a repository is now a network. So that means you absolutely have to pay attention to and care about who has access to that repository, who is submitting pull requests, who are approving those pull requests. It's incredibly important, and this is just an example, and many of you deal with this every day. This is a template. This is a template for a network, right? So, because of, as I said, the keys to the kingdom existing solely on a developer's laptop, and that shift in the responsibility, you must protect developer laptops. The talk I referenced earlier, the RSA talk, there's a link to it. This is the link. It provides you with tools to monitor, secure a developer's laptop. It gives you tools on how to go out there and look and either pay or set up a service that looks for exposed credentials, exposed keys. And I hope that you take a look at it because it has a lot that will protect you as a developer. Ultimately, because of that learning curve, because security has to get over that learning curve, there should be training between both security and development. Security, here's why I'm concerned. Development, here's how you use the technology that we want to implement. Concerns stay the same. Nothing really changes. I mean, the fundamentals are still there. And as a developer, you need to now know those fundamentals. So now we're going to talk about the cloud a little bit. This is an original, by the way. This is my art.
I learned how to use LaTeX about 2 weeks ago, so it's pretty proud of this.
I'm getting pretty good. So Cloudy McDevilface here is how security sees, a lot of security sees the cloud. The three services that, I think we all know these three services. While we're going to talk specifically about AWS, the concepts that we talk about with challenges and solutions apply to all three platforms. The problem with the cloud and the beauty of the cloud are the same. Elasticity, machines being spun up and down at will. The speed of infrastructure, code being developed, and now a network being put up in the cloud makes it incredibly challenging for security. They don't have a lack of, or they have rather, a lack of visibility into your cloud environment. They have a lack of visibility into the tools that you're running in the cloud. Ultimately, all of this they can get over, and we're going to walk through that during the solution section, but keep this in mind. Your data center in the cloud, and that's what it is, it's externally accessible. That's something you really have to understand in terms of threat and risk. So, we've got an attacker on the right. As Jack said, I've been having some fun. The three main ways that we see AWS environments attacked are through the abuse of misconfigured services, straight up not configuring services securely, unpatched machines or web applications that are vulnerable to command injection or remote code execution, and lastly, and most pervasively, access keys being exposed out there on the internet. Luckily, that never happens, right? We don't put stuff in our dot files and put them up on GitHub. We don't put them in source code and put them out there on GitHub or wherever, Bitbucket. So obviously, this is a problem. This is an example of a misconfigured service. This is S3. Chris Gates, the person again that I did the talk with at RSA, ran an enumeration tool, just looking for directories that either exist or do not exist on AWS. And performed an ls command, just listed one of the S3 buckets that were discovered, and had access and was confused to why. It's maybe not well known, and again, this is just an example of moving too quickly and not understanding the technology you're using, that anyone who is authenticated to AWS has permissions to this bucket. Sounds reasonable. Sounds like anybody authenticated to your AWS account should have access. It's not reasonable, and it's not well understood, because that's anybody authenticated to any AWS account at all. Again, just another example. You can find plenty of misconfigured services. If any of you are not familiar with Shodan.io, take a look after this talk. It's like Google for hackers. You can have a lot of fun. Here's an example of Googling, and it's probably not the easiest to see, but the point is the second I type in Elasticache, or I type in Redis, or I type in any of the tools or any of the cloud services out there, I'm going to get results. I'm going to see machines that I can get right into. They're open and exposed to the internet. I heard and spoke to a gentleman earlier today, and he's in this room, but I don't want to point him out. And I heard nobody wants to hack us. I hear this time and time again. Keywords, target of opportunity. Right? So search the internet for compromised EC2 instances, for machines that were unpatched or insecure in some way or another. This tool and talk is dedicated to taking a compromised EC2 instance and automating the process of grabbing credentials, the STS credentials stored on those machines, and pivoting throughout the network. It's such a problem, it's so pervasive, that someone automated the process of pivoting through an AWS network. This is an interesting example where on a QR thread, this one says, oh, overnight $50,000 bill from AWS. 2 points. One, read that thread, and there are a lot of people who said it happened to them. Secondly, you're financially responsible if you don't do some of the basic hygiene for AWS. This is somebody who outsourced their Rails application development, and that outsourced developer committed the overly permissive S3 access key to the internet. So let's talk about solutions. Netflix and Jason Chan at AWS reInvent gave some great tips through his talk called The Psychology of Security Automation. And the goal is for security to empower rather than to stand in the way. So this means automating and building tools to help developers. And Ryan Huber talked about the same thing at Slack. And let's just take one example from those talks. Chat ops. Chat ops is incredibly important and is becoming, if you look on the schedule, it's becoming a pretty important thing. It makes us communicating and making changes to our environments and improving things real time. So using a tool such as Netflix's Hub Commander, you can take a template, make a change, security is notified on Slack that there is a change to the network, to this template. Security either approves or denies or makes comments, whatever the case. And within a short period of time, using the power of automation, chat ops, your infrastructure can still go forward, but in much less time than in previous years, and still be secure. I have an entire talk dedicated. It's 50, 60 minutes on AWS tips, and we have limited time, so what I'm going to do is just really briefly go through this. That link will get you to that slide set, and it has everything that you need. But the basic gist is you need to harden your AWS environment, you need to monitor it and be prepared and be able to recover from a disaster or a breach. It basically comes down to this with hardening. You need to harden your IAM service. You need to harden the tooling and the services you've got inside of your environment. And when you stand up, you scale up, have secure baselines that you're working from and secure configurations that you're working from. Very simplified, but effective. Within IAM, common things that we see go wrong: do not use the root account for operational purposes. There's no need for that. Enable multi-factor authentication, not just for the web console, for the API, because most often when you see those access keys leaked, what are they going to be using? The API. So set up two-factor authentication. Whenever possible, use roles. If you're using AWS SDK, roles and AWS SDK work together beautifully. With configuring services, there's no silver bullet, but there is this guide that gives you at least a sense of what you can do in terms of what you should be concerned about with encryption, etc. And that list is sort of a summarized point on that. Alex Lucas, he gave a talk on how to automate checking staging environments for security holes before going out to prod. He talked about how to create those secure baselines. He talked about how to create those secure configurations, and I recommend you taking a look at this talk. The three services you can use built into AWS: CloudWatch, Config, and CloudTrail. CloudTrail for logging, CloudWatch and Config for analyzing those logs. And this breaks it down. But that's essentially what it is. You interact with the API or the web console, gets logged, CloudWatch and Config can be used to create alerts. And using CloudWatch event rules versus CloudWatch metrics allows you to create these types of alerts where unauthorized access has occurred, and we get a nice little descriptive image or message that tells us what IP it came from, who did it, what action they tried to do this on, what AWS account they tried to do that with. This code that gives you the code to build that Lambda function, those slides, they tell you exactly step by step how to set this up. In terms of disaster recovery, I've got a couple options on here, but to be brief, do not back your AWS environment up to the same AWS environment. I think if we learned anything from our friends at CodeSpaces, that would be it. In summary, security needs to use DevOps practices to secure developers and DevOps environments. They need to integrate with you all. But you need to not move so fast that you leave them in the dust. and ultimately create secure baselines, understand the tooling, monitor your environments, and all should be well. I'm going to hand this over to you.
All right. So we're going to talk a little bit about microservices. Really some of the things that are specific or kind of new about microservices, as opposed to, say, building big monolithic applications. We have to approach things a little bit differently. So anytime you want to look up something on a programming design pattern, you randomly stumble upon something Martin Fowler wrote. So microservices, in my opinion, in terms of adherence to strict microservice, reminds me a lot of, like, if you ask 5 people what their definition of DevOps is, you'll get 5 different answers. And if you ask 5 people what Agile is, you'll get the ones that are like, hey, we have like Scrum boards and like we got rid of requirements, but like we ship 4 times a year, but we're Agile now, right? And you kind of see that in the microservices world. And from experience, I've found that people build microservices, in a way that there's minimal dependencies between services. In terms of failability, right? Something can fail and the whole architecture doesn't go down. But in reality, you find people kind of build something between that and what you'd kind of expect in like a traditional service-oriented architecture with, an ESB, bus and et cetera. So microservices simplify everything, right? So you read these horribly misguided things, usually on Stack Overflow or somewhere like that, and they can certainly simplify some things, right? They can make your applications a lot more testable, right? So you can test things independently of other services. But then on the other end, you got to really think about integration tests, right? Because they become super important. So do microservices simplify everything? Absolutely. Whoa, I just got real loud at that point. Jumped into my mouth, actually. This is so weird, sorry. So microservices don't simplify everything. And in fact, they do tend to add quite a bit of complexity. So you can do microservices securely, but you really got to think about things at an architectural level as you're, jumped again, as you're building out the architecture, right? So as Ken kind of alluded to, these things move a lot faster. We're going to deprecate services, so it might be a Golang service this week, and maybe we're going to rewrite it in Node because we just felt like it, right? But nonetheless, you have the ability to do that kind of stuff. And usually when you find you add lines to, say, an architecture diagram, you tend to add complexity and inherently more security risks. So here's a good example. Is it a great analogy? Maybe. Once upon a time, we had that big monolithic application. So think of that as your big, Java struts, Apache struts application, right? So it's big. It's millions of lines of code at Java, right? Maybe half the code is dead. Half the code actually works. But regardless, from a security perspective, it's a well-defined architecture, right? So you know where the web server is. Maybe it's talking to one database on the back end, right? So it's got a single Postgres or MySQL backend. And then that big application gave birth to 12 other piles of small code, right? So think about each one of these things as a different microservice. One could be billing. One could be, user analytics. One could be order history, comments, you name it, right? So what we had in this one big pile of code, now we've essentially decomposed it into a lot of different places, right? And an interesting too is, which I find is really ironic, is now people are, recommending things, especially in serverless world, to use things like monorepos, right? So we've essentially decomposed things into microservices, and now we're pretty much saying, hey, let's put it all in one repository, right? Just interesting how, once upon a time we went from client server back to mainframes, or it's interesting how the trends go. So this is an example. If you think of something like Amazon, right? You think about each of those services. From the outside, it looks like one experience, but in reality, there's a lot of different services on the back end, right? It could be different technologies. Whoever you are might give you different entitlements to do things on different services. So from experience, you find that there's some things you can kind of centralize between services, but a lot of the rules you still need to leave back on the service themselves. Here's an example of what you might expect in a microservice architecture. In this example, we're tying everything together through something like Apache Kafka. So on the back end, essentially, different services, when events happen, are passing messages between them. So that's one way on the back end you kind of do still couple services in some way. At the front right there, yay right there. The API gateway. So this is a really common pattern in microservice world. So we actually do use API gateway, AWS Cognito. But the nice thing about kind of abstracting that is the services don't have to care about authenticating the user. They can just focus on what happens beyond that. But other things you'll see in the backend, for example, each service can use its own data store. So it could have, its own Redis instances, its own Postgres, so on and so forth. So one thing you'll find is really, really difficult to do, but not really, is sharing secrets securely. So does anybody, just out of curiosity, use like the native secrets management on Kubernetes or anything like that, right? So the nice thing is that there's actually options. Are they all perfect? Not really. We'll talk about that for a minute. But nonetheless, one thing you want to avoid is passing secrets between services in the clear. So bad idea is hard coding stuff into your Docker files. So Ken showed examples on GitHub, but you'd be amazed at how much of this actually happens, right? And not just people that don't know how to write code. People that know how to write code, they do things like this. If you're to use things like environment variables, for example, to pass secrets into your containers, that kind of stuff is actually accessible to every process within that container, right? So depending on which tools you're bundling, so on and so forth, things to consider. So here's an example of the most egregious way to do it. If you do this, pull out your laptop and undo this because you could do it a lot better. But this is an example of just hard coding it, right? The Docker file, pretty standard stuff. You can also pass stuff in with Docker run, right? And you can pass it in. But you have to think about if anyone uses things like DCOS or Kubernetes or anything else where you might have a dashboard where you're going to see history, right? These things potentially going to leak, right? So while it may not be in a source code repository, this stuff's in a lot of other places, right? So some solutions here. Step one. So if anybody's selling you like a new security product that's like going to scan microservices and like they invent some new cross-site something security term, tell them they're full of it, right? Things like that, issues we've dealt with for years like SQL injection, cross-site scripting, the same practices apply, right? Don't concatenate stuff into SQL statements, bind variables, prepare things. In some cases, you might want to escape characters depending on what kind of database you're using. So that stuff is still hygiene, right? The thing you do have to consider is that your data, while you may be handling it correctly in your service, so you control the source to sync in your service, but think about if you basically broadcast that out to other applications, right? Another application consumes it off of a Kafka topic. That application does some kind of persistence, right? So things to consider is that your service may do it correctly. Somebody else is going to handle that in an insecure way, right? When you're doing threat modeling, thinking about things, you totally have to think about where's your data going to end up, how's it going to be handled. Authentication authorization, they get a little tricky. So kind of like I alluded to, in a microservice world, your data ends up everywhere, right? Seen some crazy stuff. Who uses like Spark and like Zeppelin for notebooks and stuff like that? And your data science team loves to hoard data, right? That can be HIPAA data, that can be payment data. If you give them data, by the definition of their job, it's their job to analyze it, right? And hoard it at that. So you really do have to think about the data inventory as it propagates throughout your architecture. So we talked a little bit about the API gateway pattern. This is really nice because it kind of abstracts authentication from your services, and then your services can deal more with authorizations, entitlements, and so forth. So we do use this. We do dog food some of the things we talk about. We also use Cognito's user pools, etc. It's a really fantastic way to spin up authentication across a microservice architecture. Additionally, you'll use things like, for example, JSON web tokens and claims to also pass some of that identity across your services. So using a solution like this, it just kind of packages all that stuff that's really hard to develop on your own and actually get right. As security people, we still screw stuff up constantly.
Have we seen somebody mess up trying to build their own SSO, their own single sign-on?
You could also basically sign requests. So by default, if you are signing every request coming from the client, it actually makes things like, for example, cross-site request forgery. If anybody's heard of that one, it's a way to impersonate by getting using a click-on, say something that's like a GET request. It's going to do some kind of state changing potentially. You could actually break that by using a solution like this, which is pretty nice. Once you get past it, right, so you can pass all that information about the user and all their principal data essentially from the gateway back to your microservices. And then you let those services handle business rules and resource level authorizations and stuff like that. What about between services, right? So we think about the user coming in, being untrusted. You never ever trust the user. But you should also think about, for example, what's going to happen when somebody stands up a new microservice and then they subscribe to your Kafka topic. And next thing you know, you've got a new place where plain text credit card numbers are being stored, and God knows how long, right? This stuff, I've actually seen stuff like this happen. So as you're building these things out, you should think about things like authorization, authentication out of the gate, right? And especially the authorization piece, right? You should assume that at some point someone's going to be just interested in consuming that data. Maybe they're competing for your job, something like that. But nonetheless, you want to think about and restrict these things as heavily as possible as you roll them out. It's easy to do it but while you're rolling it out, as opposed to moving backwards and breaking stuff, right? No brainer. And for sharing secrets, so each of the major, container orchestration platforms has some decent options. Kubernetes, we use Kubernetes. There's examples to pass in secrets between to pods, and then essentially each of those has the ability to read that off of a mounted partition. So that's infinitely better than basically hard coding it. But things to also think about just to kind of get your brains going towards the end of this. So you still do store that in plain text. So there's a proposal, the T fell off there, to actually get that natively in there. But again, just thing to consider is that your secrets are stored and passed in at runtime securely. But there's a single point of failure if somebody gets on that box and is able to basically get those. Additionally, there's some cool research recently. If you can get in there, drop like a privileged container in there, then you could also suck keys out. So there's a lot of interesting research now about attacking Kubernetes and stealing secrets. If anybody uses Vault, Vault's still a cool option. Vault works nicely with things like KMS. Vault makes good rituals like rotating your keys easy, and you really have no excuse to not do some form of regular key rotation, right? Once upon a time, we had to get like 50 people involved. Now we have a nice centralized way to do stuff like that. So really the biggest things, see people messing up out of the gate, obviously authentication, authorization types of stuff, securely sharing secrets and understanding where their data lives and moves to in production.
I can summarize this section pretty easily. As a developer or as a security person thinking about your developers, developers always run unit tests. Let's think about that and skip forward. When you want to build a solution for your developers, or if you're a developer trying to build a security solution, you can build security-centric unit tests. And if you fail them, you don't put that code into production. A little bit more to this, but that's the summarized version. Here's an example of that. This unit test attempts to navigate to what should be authenticated resource with an unauthenticated user account. If not redirected, there is a red flag thrown. This is an example of using code build, code pipeline, and Brakeman. If you like taking pictures of your cat and you love poetry, you might be a Rails developer.
He is a cat.
I'm a Rubyist, by the way, and I do have cats. This is a good solution, or this is a good example. Codebuild.yaml specifies running Brakeman, which is a static analysis security tool for Rails. With code pipeline, new code is detected, pulled from GitHub. Code build runs Brakeman. If the test fails, you fail, or the code fails. It doesn't reach the production or staging or whatever environment. It's very simple, and that link gives you step-by-step instructions on how to implement that using AWS. This is sort of, at the end of the day, what it's going to look like, but let's summarize. Use automation. Understand the tooling. Completely understand the tooling before you deploy it. Leverage techniques like ChatOps. Use all of what's out there to your advantage. and cross-train one another. Do you have anything else to add? Thank you. Appreciate your time.
It's actually not.
Is it working? You can hear us? Okay, great. So looks like it is.
All right, everybody. Here from Flux 7, we have the CEO, Otter, here to talk about planning Docker-based microservices.
Thanks. Thanks, everyone. So a quick introduction about myself. I'm the CEO and one of the co-founders of Flux 7. In fact, I also have a faculty position here at UT, so I do actually teach on this campus. In case you're wondering, no, I have never been to this exact place before. And no, I do not get free tickets to watch the games from here, because I do get asked that. Flux 7, we have been around for 4 years. In fact, we just celebrated our 4th birthday, a team of about 50 people now, headquartered right here in Austin. And what we do at Flux 7 is help companies adopt technologies like cloud and DevOps. 2 things worth knowing about the company to understand our biases a little bit. First, Flux 7 is all about being a specialist and not a journalist. When we founded the company, the idea was that we are going to try to be the best in the world at a few things rather than trying to be mediocre at a lot of things. And second was that we firmly believe, given the background that me and my co-founder brought, that DevOps and cloud and the modern IT is about internalizing those practices. It is not something that you can say outsourced. There is no such thing as outsourced DevOps or somebody else doing it for you. So it's critical that our customers, as a consulting company, we have to teach our customers how to fish rather than trying to be just another stage or somebody who's actually in their mission critical path. So our mantra is always get in there, teach the customer how to fish, and then get out of their way, let them go, run the show from there. So the 2 biases from here. One, you will hear that I'm rather prescriptive about some of the technologies that we work with, because that's our goal. And 2, the kind of customers that we work with are the ones that are wanting to internalize these things and do it themselves, not necessarily looking for, say, a managed service provider. The 2 strategies have generally worked very well. Just want to quickly share a few things. In the arena of being a specialist and not a journalist, we have actually been awarded by AWS several competencies, partner recognition award. The Tech Target guys have actually done best AWS consulting partner competition. And for the last 3 years in a row, they have actually rated us the best in the ecosystem. A completely merit-based award with no money involved. It's often important to say that. And purely based on customer feedback. Perhaps the most interesting metric, though, that I really take a lot of pride in, that they teach the customers how to fish. The idea was that this will enable us to increase the adoption of these technologies quickly at our customers. Rather than us doing it, teach them how to do it. And that strategy has worked quite well, in fact. We have had customers of ours getting invited by AWS to share the stage at the keynotes with Andy Jassy and Werner Vogels. We have had our customers getting invited to AWS summits, reInvents, to come and share their success. And in most cases, the best part is that when they get invited, we only were the ones who started their journey, but they have been running on it on their own and have created such a big impact that they rise to the top and get invited by AWS to come and talk about how successful they have been on their platform. AWS is just one of them. Technologies we work with, we are one of the 8 Docker Foundation partners in the world. We are one of the handful of people who are partners with HashiCorp, and in fact, one of our projects was mentioned by Hashimoto during his keynote at HashiConf last year. I've been personally invited to talk at a couple of Docker cons. So that's that Flex 7 philosophy. Try to be the best in the world at a few things rather than being mediocre at a lot of them. So why did I choose this topic for today, the Docker-based microservices? Because I personally believe that there are 3 very interesting patterns that are happening, and luckily they are all happening right at the same time, which makes Docker-based microservices specifically something that I do firmly believe every one of us is going to either have already come in contact with or will be coming in contact with over the next few months. Those 3 patterns, first of them is microservices. It's a code developer-related pattern. They don't require each other. Again, very important to say. You could have microservices but not necessarily have true DevOps. You can have DevOps and not necessarily be microservices, or you can have both without Docker. But it's the synergy that actually makes them very interesting. So microservices, the previous talk did an excellent job of talking about microservices, and I won't just belabor the point again. But the idea is very simple. Instead of writing the application as a single monolith application with just defined roles, a very standard would be just an application and a database tier. You write it more in the context of smaller services, say 2 microservices here, M and N, having their own databases and then having connectivity between them. Often, the idea is that you have individual separated components that can be worked on in parallel, with the aspiration that we want to provide agility and improve productivity of the teams. And this comes in many forms. For example, when working with startups, I've noticed that microservices are primarily brought in with the idea that agility is what you need. You want to be able to pivot very quickly. And the more flexible the framework is, the quicker you can pivot. Some of our largest customers, like traditional Fortune 500s or Fortune 100 companies, bring in microservices, but if you really try to explore, what they're trying to do is they're trying to compete with these startups, but they want to leverage the sheer scale that they have. For example, if I have a 100% developer team, I can actually break things down into microservices, 2 pizza teams, and actually enable them to go a lot faster, competing with the new upcoming companies who are giving them competition. But the overall idea is it's about agility and productivity that microservices bring to the table. The second trend I mentioned was DevOps. Just to explain it very simply, as I've been lately trying to crystallize what DevOps means, because it's always been a buzzword, and what it means to Flex 7, I'll just use our view of the world to explain it. So in the more traditional framework, the idea was that you had the service teams, the application teams, if you will, that are primarily in charge of their own code that is to be deployed. You would have QA release teams working in the middle that will then eventually hand over those artifacts into a more traditional IT ops framework, where the IT guys, the operations teams, would be in charge of both the service agnostic components that are just your racks, your data centers, your networking, etc., as well as the service specific components. For example, having the task of getting a MySQL 5 database up and going before an application can in fact be deployed. So application dependencies often would be on the operations teams. And then there is this broader concept that I'll reuse on the next slide again of inspectors, where and I just use that term broadly to say that there are certain things that just need to be checked and monitored in your environment. In the traditional world, inspectors are primarily related to what are you trying to monitor in production. So system metrics like CPU, memory, etc., etc. What we have seen, and I often find myself saying this, that what you're seeing on the screen is not necessarily something that we came up with. It's more a learning of having worked with about 150 companies going through the DevOps transformation as a consultant. At Flux 7, we've just seen what patterns actually emerge and where do most people land or have the vision to land. And we try to embody that into this very simple diagram here, which is that one of the key differences is the service teams are now being asked to own more and more, not just the code, but in addition to that, configuration. For example, your Chef, Puppet, Ansible components, the infrastructure like your Terraform, CloudFormation, things that actually create the virtual machines, but everything specific to the services. Or another way of saying it, the service code and all its relevant dependencies are owned by the service teams. The traditional operations gets converted into this concept that we just call landing zone, where it's really, and the key operative word there is the service agnostic components where services can land. And then you have these pipelines, which are just processes that will land the services into the landing zone. That service agnostic is very critical. We'll come back and actually hit it one more time. And the concept of services themselves owning more of their dependencies. And then there is this inspectors, which just come in two flavors in this new world, as we have seen. Inspectors that inspect things as they get through the pipeline, and inspectors that inspect things once they're running in the landing zone. In the landing zone are the more traditional stuff, but there are security checks, audits happening that are happening on stuff going through the pipelines. And then very lastly is this concept that we just call injectors. When you actually have a framework like this where things are going full speed, the last thing you want is people having the need to communicate with each other. For example, information specific to the landing zone to the service team. For example, what is the subnet ID or what is the CIDR, things like that. So the broad concept is that what most of the companies that we work with, we find them doing as they reach their full potential, they actually have automated tools that will inject environment-specific information into the service templates on the fly while things go through the pipeline. A very concrete example of this, by the way, is what the previous talk also mentioned. For example, the use of HashiCorp Vault and HashiCorp Console for having your services information and your configuration information in there so that services can pull them when they need them. And why are we doing all of this, and why do we talk about all these different components? The idea is that you want to be able to allow these operation teams and these service teams at their full potential, at their full speed. A lot of our customers are marching towards this journey, or to some extent gotten there one step at a time. So that was the second trend. The third trend, clearly, that has taken our industry by a storm in the last few years is Docker and Docker containers at large. What are containers? I don't think I need to do a deeper introduction here, but this is this idea of these containers that contain the application code artifacts, other components around it. A container would typically have its own file system, has its own process space, and creates this isolated container where a single service or a single code could in fact execute. And where this begins to fit into the other two components we talked about is that containers actually provide this layer of abstraction between the infrastructure and the applications. And tying this back to what I was talking about DevOps makes the two extremely synergetic with each other. So that takes us to the idea of Docker-based microservices. There's the same picture again, but just translated into the world of microservices and the world of Docker containers. It's actually one of the most natural ways of getting to a framework like this in your organization. Services, or as we call them now, microservices, just consists of just how Docker naturally works. There is the application code. There is the Docker file that is carried with the application code, which contains the dependencies of the application. There are descriptors of the service itself, which tell the orchestration fabric how much CPU or how much RAM you want to give to a particular service, or how many containers of a particular service that need to run. Just naturally, Docker almost requires all of that stuff to be with the service, to be kept with the service, just the way you would want it to be if you want it to be at full potential. There's the need for the pipelines to land these services into the landing zone. And the beauty of it is that the job of the pipelines becomes extremely simple with containers, because in the non-containerized world, we find ourselves writing these very customized processes for delivering services into the landing zone, a different process for Windows, a different process for Linux, a different process for Java, a different process for Node.js. With containers, you actually can abstract a lot of that information out, and it actually makes it a more natural fit to this model. The landing zone, as I specifically stressed, is the service agnostic part. Well, that's basically what a Docker orchestration fabric like Kubernetes is, or ECS is. It's just a place where you can throw containers and services that just run. And it does not, when you set the framework, you don't care about what the service is. When you write the service, you just know that you're going to be running on an orchestration engine. You just need to know which one it is going to be. You don't really care about the specifics of the engine itself, of the deployment itself. So it makes the service agnostic to the landing zone and the landing zone agnostic to the service, which is very critical to DevOps at large. The inspectors, I mentioned earlier, there are two types, some that inspect things in the pipeline. There are some traditional things like lint checking, security analysis that you would have done anyways. But there's some really neat stuff that you can actually do with containers from a security inspection standpoint, that before anything gets deployed or run, you can actually do a static image analysis on a container to check for vulnerable software in your container. And that gives you a whole new level of security and vulnerability analysis that is typically not done in the world of virtual machines. There are inspectors in production. Nothing really heroic or new there. You have the same stuff like your CPU, memory, logging, vulnerability detection, etc. And then when it comes to injection of information about the landing zone into the services, containers generally make this process really easy because they're just inherently decoupled. The only major thing that's left there to inject into your services is just secrets, things that will allow us to authenticate one service to the other, or allow a service to authenticate to an outside service or another database, etc. So secret management. So it takes that complex things of those three patterns. You can really break this down into, I just have a series of a handful of decisions that I have to make. I have to choose a good orchestration engine. I have to choose a good repository structure. I have to choose what my inspectors and pipelines look like. And a framework begins to emerge that is actually a pretty natural fit to what a lot of us are trying to do, or a lot of us are trying to get with DevOps at large. And almost everything that you see here can be agnostic to the service itself, which makes it so that we can actually focus mostly on the service agnostic components, and the development teams, the service teams, can worry about the services and how they will actually use the rest. So just to tie it back to the real world a little bit. So we started seeing a lot of these patterns emerge about a year or a little over a year ago, when all of a sudden you would pick up the phone. We, being a consulting company, just get calls from customers all over of all sizes, and almost every call that we were getting was actually asking us for, we know that you guys could do Docker, we know that you guys have been talking about DevOps, and we are looking to go microservices, can you guys help us? And we started to kind of try to understand what is actually going on, and B, as a consulting company, it's one of your nirvanas where you can actually build things that are agnostic, and you can actually rubber stamp them for people as they are coming around. So we started to take this information that I just shared with you and started to look into how could we actually break this into a very simple sequence of decisions that one has to make in putting a framework, the few choices that have to be made, and how you can put these things and glue them together to put a Docker-based microservices framework that can work for a majority of our audience, a majority of our customers. So what I'm going to do next is to actually walk you through an example. Example is worth 1,000 words. So while I'm going to go through the top 10 decision points that we walk through with any customer that comes to us asking for a Docker-based framework. But I think what's more interesting is that I took one of our customers, one of the more interesting deployments, and we'll just use them as the architecture as an example as we walk through the decision-making process of the different elements. So first off, a little bit about the context. It's a very large healthcare solutions company based out of West Coast, over 1,000 people. They had a monolith application written in .NET for several years. Well, where several is just 5 years, less than 5 years, but it's infinity in our world these days. The challenge was that the team had grown to about 50 or so developers, and the application was stifling innovation because no one person knew everything, no one person had the full context. You hire a new person, it took forever to onboard them, and their need was to look at Docker-based microservices. So to my point earlier, the title of my talk, the top 10 considerations, we'll go through this list just one element at a time. So first of the questions that you want to discuss and ask yourself if you're going along this journey is, perhaps the most fundamental thing about microservices is that we have to allow faster deployment. So you have to figure out the first process, how will an existing microservice be updated? In our experience, the common considerations around this are, what are your current flows? We have tried to go in and just create a revolution with changing people's flows. Never really works. In our experience, you have to take their current flows into account as you build what the new framework could look like. There's skill levels. It's not easy to kind of go in and change everything. And then any technology inclinations. If people are familiar with Jenkins, Jenkins is a good answer. So for this particular customer, just to throw a more concrete example out, they were already using Bitbucket. They were already using Jenkins. We really went with their technology rationalization. The only major thing we made different was add some of those inspectors and security analysis, etc., in their pipeline, leaving most of what there was intact as is. The second is another very fundamental thing to microservices. What does it take to start a brand new microservice? Because it has to be easy, otherwise eventually you'll end up with a few monoliths all the way back. The major considerations there are, how much can we automate, how are we going to maintain security, and how do we maintain self-service? This is in the healthcare space, so HIPAA compliant. Clearly, you're talking about two competing priorities with how do I enable people in self-service while still maintain separation of duties. So for this particular customer, we actually did a rather innovative setup, and actually one of my favorite blueprints of how to actually do this. This was in AWS, so we took advantage of the AWS service catalog. For somebody to start a new microservice, you would just go to the AWS service catalog and press a button. It would create a code repository. It would set up the ECS services, get the framework going. A second step was to actually, and it would actually create for Jenkins 2.0, create a sample code repository. People would start pushing. The developer can then just push code into the code repository, goes through Jenkins, gets deployed. We'll talk about the other components here in a second. But again, by no means I'm saying this is the only way to do it. I'm just giving examples of what are the things you need to be thinking about and what are the tools you could play with. Just to give you an idea, this was actually one of the developer portfolios in the Amazon Service Catalog where IAM permissions could be created for an application from a pre-existing template. So you don't give anyone the ability to create any permission they like. Instead, you restrict what they are allowed to do with pre-existing templates through the catalog. The third one is services. As they will come up, you have to have a mechanism to assign them URLs in a completely automated fashion. Otherwise, again, we're back to the same problem of making it hard, making it a monolith. Some considerations there: it has to be scalable, your solution has to be versatile, it has to be secure. This one's a rather standard pattern that we used for this particular scenario. We used the HashiCorp console together with console template, registrator, and Nginx as the API gateway. New services come up. Based on the name of the service, say a demo service, a new URL gets assigned with no human intervention. And as newer containers in that service come up, they automatically get added to the load balancer. The next two are, you have to have a mechanism where if a container fails, it deals with it on its own, does not require human intervention. And then next, need a mechanism where I don't have to think about how to schedule containers on the different nodes. Actually, the answer here is rather simple. There is actually some really good Docker orchestration tools out there, container orchestration tools out there. All of them have those two basic features, that they can recover a failed container and that they can actually take care of the scheduling for you. Could really pick any of them. Again, not trying to be prescriptive, and there are pros and cons. It's a much deeper discussion. But for this particular customer, we actually ended up with AWS ECS just to give them a quick jump start on the AWS platform with containers. Then the second half of the considerations are more around technology, less around the process. The first of that is, how will the code for each microservice be structured? In fact, this came up in the previous talk as well. The choices are, do you want to put all your services in a single repository, or do you want to have one repository per service? The answer really depends on how much separation do you want between the roles that within your company, and how is the team structure. In this case, large company, lots of dev teams. So we actually ended up with a Git repo structure where you had one service per code repository, and the code repository then contained things related to that service, including its pipeline definitions, Docker file, the code, the configuration, and the infrastructure needs, if you will, all in the same repository. Then there were three other considerations. One, and again, they're very closely tied to each other. The first is about load balancing. I have a service with multiple containers. How are we going to balance the load between those services? Then I have multiple services running. How do a new request coming in, how do I direct it to the correct service? That's the functionality of an API gateway. And the third one is, you have to terminate your SSL somewhere along the way as well, and it's actually an important consideration with microservices. So the things that you need to think about are session stickiness requirements around load balancing. The sheer number of microservices actually can dictate what can you use as your API gateway. And then your SSL termination is driven by your security and compliance requirements. So what we ended up for this customer was a very simplified version of the diagram. We really just had an Amazon load balancer. This is back in the day when the ALB was not launched, worth mentioning. This is the Elastic Load Balancer that actually hits an Nginx, which acted as both the load balancer and the API gateway. And then we had console, HashiCorp console, as I mentioned earlier, for the service discovery component. And SSL in our case, because of HIPAA compliance requirements, we actually had to terminate it at the service. We could not terminate it at the load balancer or at the API gateway, because HIPAA requires end-to-end encryption in transit. And then last, but perhaps the most interesting, is the piece of, how do I get my secrets to the code that is actually going to be running, the services that are going to be running. The general considerations quickly, there are the number of secrets, the expected growth in the number of secrets, because that dictates your decision a bit little. How paranoid are you about security? HIPAA compliance obviously takes you to the extreme. Then your willingness to change your application code is a very important factor as well, because there are some really powerful tools like the HashiCorp Vault, which we ended up using, but it actually did require the service teams to make some code changes. And admittedly, it was not well received at first. It took a lot of convincing. And in the code repository list I showed earlier, you may have noticed there was a file called wrapper.sh. That was for the teams who absolutely did not want to change their code. We wrote a wrapper script that will get the credentials from Vault and just put them in as environment variables when the service started. but those are all factors that would actually go in. We chose Vault because in this case, HIPAA compliance at most security was in fact required, and the workflow was and separation of roles and the way Vault works actually made it a very powerful choice. Just in case you're curious on what some of the other choices that we have worked with, the EC2 parameter store in Amazon is a new solution on the block, and it's definitely interesting. Ansible has a Vault baked into it. Chef actually comes with the encrypted data bags. So there are other solutions out there, but HashiCorp Vault served the need really well in this scenario. So the final architecture, just to do a quick recap, Jenkins as our orchestration for the processes, a simple ECS cluster with Nginx, Vault, and Consul in the backend for secret and service discovery. We actually use some other AWS tools for monitoring infrastructure as code and the code repositories. So what's the point? Why did I go through the example? So first, I do believe that nearly everyone is going to need a solution for Docker-based microservices the way things are trending today. Second, that it is important to design that framework for productivity, agility, and security, and that layer of abstraction is extremely critical to separate services from the landing zone. And our intent here was to share with you guys this guideline that we use as a consulting company working with every one of our customers on helping them design their framework to turn this into less of a mystery and more of a puzzle where you know the 10 blocks that you need and how do you put the 10 pieces together is where the customization comes in. So with that, that brings me to the end of my talk. Any questions? Any questions I can answer for you?
Is there any possibility to get your slides?
Sure. I will don't have them uploaded anywhere at the moment. We did share them with the organizers, so I'm not sure. I assume that will actually get uploaded to the conference webpage at some point.
Website shortly after the conference.
Sure thing. Right. Thanks everyone. Thanks for your time.